Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics. The topic discussed is PV diagram part 3. We have already discussed part 1 and part 2. This is the last part under that series. In this video, we will discuss PV diagram for isobaric, isochoric and cyclic processes. This video will be of great use to you. So watch the video completely without skipping. And if you think the video is useful, do like the video, share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. And press the bell button and all button for notification of more videos like this. Thank you very much for your support. Come, let us start the class. Now we will see the PV diagram for isobaric process. In the case of isobaric process, pressure is constant. So what will be the nature of the graph? We will first take up expansion work. So this is the graphical representation. X-axis change in volume is taken. In Y-axis change in pressure is taken. O is the origin. Pressure is constant during the process and volume alone changes. The shape of the graph is a straight line parallel to the x-axis. V1 and V2 are the initial and final volumes respectively. You can understand V2 is greater than V1. So, change in volume will be V2 minus V1 equal to delta V, and it will be a positive value. What is the expression for work done? Work done is equal to P delta V. It becomes a positive value. But what is the significance of PV diagram? Without using any formula, we can calculate the work done from PV diagram. That is, it is the area under this graph. In this case, the area under the graph will be a regular shape. So all you have to do is consider delta V. And this is the measurement of the pressure. This value gives measurement of pressure. So P into delta V is the work done, and it is positive work done. Because it is expansion work, work is done by the system on the environment. Okay, so when we calculate the work done from PV diagram, work done is equal to area under the graph. It is very easy. Now, when we apply the thermodynamic equation, delta Q is equal to delta U plus delta W. So, from this, delta Q minus delta U is delta W. We will write it in the correct format. Delta W is equal to delta Q minus delta U. From the representation of the thermodynamic equation for this process, we understand part of the energy is used for increasing internal energy and part is used for doing work. What is change in internal energy? That is delta U. Delta Q minus delta W is equal to delta U. In the correct format, I will write it here. Delta U is equal to delta Q minus delta W. This expression and this expression you have to remember, questions are asked from that. This is for isobaric expansion work. Compare this with the equations obtained for the other type of processes as well. Now let us consider isobaric compression work. Work is done on the system. The environment is doing work on the system. So work is negative. The graph is just like what you got in the case of expansion work. It is a straight line parallel to the x-axis. This is the initial volume. V1 is the initial volume and V2 is the final volume. This is just the reverse of what happened in the case of expansion work. Here V1, that is initial volume, is greater than final volume V2. I am sorry, this should be final volume minus initial volume becomes V2 minus V1 is equal to delta V, and that is equal to negative. So work done P delta V is equal to negative. Work done is equal to area under the graph. Here also applying thermodynamic equation, delta Q is equal to delta U plus delta W. Here delta W is negative, therefore negative delta W is equal to delta U minus delta Q. Delta Q minus delta W is equal to delta U. That is change in internal energy. Note this relation. I hope it is clear. We will proceed with isochoric process. PV diagram for isochoric process. In isochoric process, volume is constant. So when the graph is plotted, we get a straight line parallel to the y-axis. When pressure changes, volume remains constant. So the shape of the graph is a straight line parallel to y-axis. So here delta V is equal to 0 because volume is constant. So work done P delta V becomes 0. That is, no work is done. Thermodynamic equation delta Q is equal to delta U plus delta W. Delta W is equal to 0. So what happens? Delta Q is equal to delta U. It can also be written as delta U, change in internal energy, is equal to delta Q. That is, all the heat that is supplied is utilized for increasing its internal energy. Delta W, that is the work done, is equal to 0. So remember these expressions. This is essential for examination. Since volume is constant, compression work also cannot be done. I hope it is clear. Now we will proceed to see PV diagram for cyclic process. What is cyclic process? In a cyclic process, the system starts from an initial state, then passes through several states and finally returns to the original state. So here the initial and final states are the same. In between, the system undergoes various changes and its state function keeps on changing. But finally, it acquires the original state. That is a cyclic process. For easiness of discussion, we will consider a simple case where a system first undergoes expansion to a certain limit of the state function and then undergoes compression whereby it reaches its original state. That is, it compresses to the initial state. So in the first step, it is doing work on the surrounding. So it is positive work. And in the second step, during compression, the environment is doing work on the system. So the work becomes negative. So let us plot the PV diagram for expansion work. We get the curve ABC. Volume increases along the positive x-axis. V1 is the initial volume and V2 is the final volume. V2 is a bigger value and V1 is a lesser value. So V2 minus V1 is a positive value and work done is equal to positive. From the PV diagram, the area under this graph, that is this area, gives the total work done. After attaining the state at C, it undergoes compression to state at A. That is, the system returns to its original state. That is, a PV diagram for compression can be represented like this. C, D, A. It is in the opposite direction. For this process, you know, the initial volume V2 is greater and the final volume V1 is smaller. So V1 minus V2 becomes a negative value. Work done is negative. Now from the PV diagram, the work done will be only this area under the graph CDA. In order to help you understand it better, I will draw separate diagrams for the two processes. For expansion work, the work done is equal to the area under the graph ABC, the whole area. That is ABC, V2, V1, A. This is the PV diagram for compression work and the area under the graph negative CDA, V1, V2, C is the work done during this process. It is marked negative because compression work is negative. When we add up these two, we get the total work done. One is positive, one is negative. Remember that. So, work total is equal to ABC V2 V1A plus minus CDA V1 V2. See, this plus and this minus. Here it becomes minus. Like quantities on both sides can be cancelled. So this A and A, C and C, V2, V1 on both sides get cancelled. A, B, C, and D remains. The area pertaining to this alone is the total work done. Let us come to diagram 1. This is diagram 1. This is diagram 2. This is diagram 3. Let us come back to diagram 1. In this diagram, this is the area represented by this A, B, C, D. Let us demarcate that area. The green shaded region is the total work done. I hope this video was of great use to you. If you think the video was useful, do like the video, share the video with your friends who may also be benefited. Also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.